Hello everybody, senors and senoritas, children of the one true God. This is Brad the Guitologist coming at you with another video here on the bench today. We have a Craigslist purchase, and for you people in Europe who don't know what Craigslist is, basically that's a place where we Americans go to sell all of our junk when we can't have a boot sale or a yard sale. Or we've got all of our crap left over from the yard sale and we have nowhere else to put it, so we stick it up on Craigslist and move it along. But that's where I found this thing on Craigslist. It's a little Valve Junior by Epiphone. The Valve Junior is a very simple amplifier, just an on-off switch, one volume knob, one input. It has an EL84 or 6BQ5 if you're in the US. For the output, and it has a 12AX7 for the input stages. What we are going to do with this is we're going to see what kind of modifications we can make with it to turn it into a little growler amplifier. It probably already is somewhat of a growler. We will do a before and after comparison and see what some cool modifications can do for one of these. So if that sounds like something you'd be interested in, please stick around. Alright, here's the rear of the unit. As we can see, we have an 8-inch eminence speaker back there. We'll get a little better look at it in a minute. We have, let's see, have some information on the back here. Made in China. That's the first thing that jumps out at me. The People's Republic of China, which I think that stretches the definition of republic a bit. However, it's made in China. The model is Valve Junior Combo, power consumption 35 watts, yada yada yada. Some of your other all-important, see, you know, whoever even looks at this crap. Intertech, what is that? Intertech CM listed. There's your CE listing, all that crap. Don't throw it in the garbage, which don't tell Guitar Center that, they'll do it anyway. Or I guess for you Brits, that would be, I don't know, maybe Dawson's would be your equivalent. We have 4-ohm speaker, 8-ohm speaker, and 16-ohm speaker taps, which is kind of cool on an amp like this. I mean, you don't really ever see that on a small combo. It does offer you some flexibility. Now let's take this back door off and get a little better look in the back. Alright, here we are with the back door off of the amplifier, and the first thing I notice is that the back door, let's see, let's get the back door, I'll show you. The back door to this thing is actually plywood, believe it or not. This is probably one of the cheapest little amps that came out under the Epiphone name. Well, I'm sure it is, but it's plywood. Huh. I don't know what kind of quality the plywood is, but it's definitely plywood and not some cheap ass chipboard stuff that just falls apart. The baffle is also plywood. You can see the wood grain underneath the, you can just get outlines and stuff here and there of the wood grain, and you can knock on it. Might not be as apparent on the video, but it actually is plywood. The whole cabinet, in fact, appears to be actual plywood and not some cheap ass glorified cardboard, which is what you get most of the time today. You know, I spend a lot of time on my channel yammering on about this stuff because you're getting less and less for your money all the time. You walk into any typical Guitar Center and that's the way it is. You know, you get what you pay for. If you want something that's of decent quality and it's not going to fall apart on you, I mean, literally, I have pulled amplifiers out of Guitar Center's dumpster that were broken in half because the cabinet was dropped in shipping or something like that. You know, and I end up like reinforcing the cabinet and using the amp. But you know, that's what ends up happening. You end up with a lot of trashed amplifiers because they can't stand up to any kind of road abuse because they're made of glorified cardboard. And if you want to know if your amp is glorified cardboard, take the back door off of it and inspect the inside. And I guarantee you, if you've bought the thing within the last, you know, 5-6 years, something like that, it's probably cardboard. This one came out, obviously, a little bit before the whole cardboard craze, and it actually is all plywood. The Eminence speaker is a Chinese Eminence. It's not the Kentucky Eminence, which are made actually just down the road from me, and we might actually go explore the Eminence factory one day. I know that they do allow people to come in and tour the factory, so we may actually go tour the Eminence factory one of these days if you guys you know, subscribe to the channel, and look forward to that. We see here this EL30, or excuse me, the EL84 rather, it's obviously it's not 34, is a groove tube. What is this? Let's see what the AX7 is. If I can pull that now. He's going to be stubborn. Oh, there we go. That one is a JJ 12AX7. And I have to say, man, this thing looks halfway decently built. Just, you know, from what I can see here. Let's get the chassis out and see what the inside looks like. Alright, actually, before we go any further, it might be instructive to do a before video here. And what we're going to do is just play it with a Telecaster. And this is a 2000s Tele. We have a Seymour Duncan in the bridge, and we have a TV Jones in the neck. And I'm just going to play a few chords here and just kind of get a sense of where we are without any mods. And this is with the amp cranked, and it actually is a lot louder than I kind of expected. Hear how brittle that is, though. Listen to the brittleness of that. And I'm on the bridge pickup at the moment. Really brittle, really kind of tinny and thin, almost like the tone's about to fall apart. Here's the neck pickup. Same kind of story there. Just really brittle sounding, not very inspiring, to be quite honest. We definitely need to tighten up the bass. It sounds to me like, I don't know. I think we're gonna have to go through it with a fine-tooth comb here. I know for a fact we can improve upon this. So let's see what we can do. Alright, here we are inside this little Valve Junior. I do not have a schematic yet, but we're just gonna preliminarily take a look at the build here and the quality of the build. And you know what? I have to say, I am fairly impressed. I mean, I don't really like these board-mounted sockets like this, but if you'll recall the Mesa Boogie video I did quite recently, these are the same sockets. It has pretty much the same build quality as that Mesa. As far as the board, the construction, the way everything's put together, the build quality is very, very much on par with that Mesa. Go watch that Mesa video and you'll see what I mean. I mean, if you just got a close-up like this, you would, and the board wasn't black, if it was more green like the Mesa, you would almost think that you were inside the Mesa as far as the build quality. So very, very similar. I have to say I'm fairly impressed by the build quality. I mean, the fact that they have an independent pot, it's not attached to the board. The input jack is not attached to the board. It's run with a wire. This contributes to better reliability. It's easier to replace these parts or to fix these parts separately from the main board. Or, you know, if they come loose or something and they're spinning around freely, they're not gonna break leads on the main board like they normally would. Or even if they're a little bit loose, you know, it's not gonna be a big deal. It really increases reliability. Back here on the same as can be said for these jacks on the back for the outputs. Those are on their own independent board. And just really fairly neat layout. I mean, very clean. I have to say, man, this is quite a nice little amp for the money. You know, I can't really shake a stick at this. You know, I wouldn't expect this to be point-to-point wired or anything like that for the, you know, what you can get them for, especially secondhand. I gave $100, I think, for this thing. You know, maybe even less. I can't remember. It was 80 to $100, something like that. Something silly. I mean, for a little valve amp. And we're gonna really soup this thing up, and I think it's gonna sound really good when we're done. Let's go ahead and get a schematic and see what it looks like on the schematic. All right, if you go to Google and type in Epiphone Valve Junior mods, you're probably going to find pages upon pages of stuff to read through where people have pretty much already trodden this territory. I'm not going to listen or read any of this crap. I'm just going to assess it on my own, take my own approach. You know, this is kind of an exercise in seeing how simple it will be to figure out mods. You know, how easy it'll be to kind of turn this into something that's a lot more useful. I'm not into paint by numbers or following lead of other people. Now, you know, there's a lot of good pointers and things that other people have learned that I'm sure I could learn from. If I were to read through all this first, I would probably end up perhaps with a better amp. But that's kind of not the exercise here. I don't want to jump straight to a conclusion. I would rather go through this and fail and fix and fail and fix. It makes a more interesting video that way. So what we're going to do is we're going to look for a schematic and just start from there, actually. Oops. Alright, I found 2 or 3 different schematics. Apparently everybody and their mothers had a crack at this thing and even drawn a schematic. This one is about the clearest though, so we're gonna use this one, I think. Here is the signal path, and here's all the power section down here. And I want to go ahead and thank this gentleman for providing this schematic, because Jack Orman, you did a pretty good job. Pretty clear schematic, at least from what I can tell so far, so thank you for that. Okay, we see here we have an input, but this is interesting. Okay. One of the other schematics that I saw had a 68K and a 68K. But this one does have a 1 meg, and I believe that's what we have in the actual amp here. And the good thing about this schematic as well is it lists the R1, R2, so it actually, you can cross-reference it easily with the actual amplifier. It makes it hell of a lot easier when you add these R1 and R2, you know, C1, C2, and etc. One note he did make about this amp, and I checked in the amp as well, and sure enough, he's right. There is no C10, so it goes up to C9 and then it skips C10 and then labels a C11 on the board. It's kind of funny. But anyway, I digress. Let's go back to the input. We have a 68K, which is pretty standard here. If we wanted a few more highs, we could down this to, you know, like a 47K, something like that. 68 should be fine though. That's kind of the Fender value. The 1 meg is pretty standard as well. We will probably leave these. The brittleness is the first thing I'm gonna try to address here, and you know, to address that, we are probably gonna have to eliminate some highs. Kind of roll off the highs just a little bit. I think even with a Les Paul, this would be. I'm thinking this would be brittle. There's not enough bite on the notes. If you go back and listen to the preliminary test that we did, it's just really brittle. There's no bite. There's no kind of punch behind the notes. It's just it breaks up, but it breaks up like it's going to fall apart. And I think some of this might have to do with biasing, and some of it might also have to do with these bypass caps. It looks like they just kind of did a paint by numbers here. I mean, just the way it's laid out, it's like, okay, we'll just slap this gain stage on, and then, oh, what the hell, we'll just slap the same stage on the next one, because you can see they're the same values. It's like 1.5 22, 1.5 22, 1 meg 1 meg, 0.0 22, 0.0 22. It's like they're like, ah, fuck it, you know. 100 no, nobody will know the difference. It's just, you know. So what we're going to do, we're going to experiment with, first we'll go through the first gain stage and try to tighten the amp up as much as we possibly can, just modifying one gain stage at a time. So we will do a modification, for instance, and listen to it. We might actually bust out the decade boxes again for our resistor and capacitor, and you'll get a chance to see those. This is another kind of curious thing. They have a 1 meg resistor here through which the signal passes. Then they have a 1 meg to ground, which is unusual since they have another 1 meg here. It's almost, again, it's almost like they painted by numbers, except here they put a 1 meg instead of the 68K. Do you see what I mean? And then they just kind of, as an afterthought, they kind of tacked on the, oh shit, we forgot a pot. Let's put a pot in here. Can't forget that. Okay. It's like they went back to the design board after the fact and was like, oh, hell with it. You know, they won't know the difference. But I know the difference, and I think you know the difference, and you can hear the difference, and this can definitely be improved upon. Alright, so the first components we're going to mess with are going to be these two here, this bias resistor and bypass capacitor, and those are R8 and C4, and they are over here on this end of the board. These two components right here, we're going to have to lift this board to remove these so that we can insert some leads and start trying to crack the code. Alright, here's the underside of the board. The two components we are interested in are right here. We're going to remove this little capacitor. And I'm just going to desolder it. I'm not going to bother with my braid sucker or anything. Alright, I've busted out the resistance and capacitance substitution boxes, also known as decade boxes. These were made by ICO. Longer term viewers to my channel will recognize these from some other videos. But what these are going to allow us to do is experiment really easily with switching out resistors and capacitors in this circuit, so that we don't have to keep soldering and desoldering and soldering and desoldering. Now we could just use our alligator leads, but then we would still have to go, you know, find a new capacitor, hook them up to the leads, find a new resistor, hook them up to the leads. This way we just flip a switch and it's a hell of a lot easier. Alright, this is the point where real fancy people would probably get out their signal generator and their scopes and they'd start crunching numbers and all that crap. But we're not going to do that. We're hooking up the actual cabinet that we're going to be using and listening to the amplifier out of. Without listening to the actual cabinet, it's not going to tell you jack shit. You can have all of the fancy crap on your bench that you want, but it's not going to tell you what your amplifier is going to sound like through a speaker. So this is the way I choose to go. So let's go ahead and set our ICOs to the values that this amp came with, and then we will start with that and modify from there. Actually, for the first part of this testing, I forgot to mention, we are going to start with a discrete component on the capacitor. This is a 25 microfarad. We'll begin with this, and then we'll kind of probably move our way downward. I don't think we're going to be going upward, at least not on this first stage. On this first stage, what we're trying to do is shape the tone more than give it punch. So we're going to shape it and probably go downward from this. And we may even get into these really small values at some point, so we have our ICO standing by. Alright, we've got the Variac powered up, and let's just flip the switch and see what happens. I'm not even going to bother dialing it. Okay, and remember, these are the values that we started with, so still got brittleness. So let's see. Let's start with the resistor value. I'm going to actually raise the resistor value. Let's go up to about 3.3K. So that's roughly doubling the value. I think a lot of the brittleness might be coming from the capacitor, actually, and my hunch is we need to get rid of that larger capacitor because it's just pounding through a lot of lows that are kind of expressing themselves in a very sloppy way on the output. I know that I'm not really making much sense here, but it makes sense in my own head, so bear with me. But here's what I'm going to do. I'm just going to remove this. And you'll notice here we can actually test it also with no capacitor. So let's test it with no capacitor and see what that sounds like. There's some less lows, but it's not like there are no lows. Still just not very inspiring. Let's do some more experimenting with this. Alright, for now I've changed the value of this bypass capacitor to 0.047, which is drastically reduced from what it was. And we're going to make up that little bit of loss of base by going with a larger capacitor right here. Instead of this 0.022, what we might do is go with like a 0.05, something like more like that. Yeah, I think that's going to be a little bit better. Then we're probably just going to replace this R6 value with a jumper wire, or just jumper around it, and then delete this 1 meg resistor, and we may add a grid stopper resistor into this next stage right here, something probably on the order of, say, 220K, something like that. And what that's going to kind of do is that's just going to smooth over some of the highs, and if it still seems like we're getting too many highs, we may come back to this first stage and put a very small capacitor from the plate to ground, or possibly even from the plate back, feeding back to the grid, a very small capacitor. And what that's going to do is that's going to have the effect of also mitigating some of the highs. Alright, I've removed that coupling capacitor right there and put some leads in its place so we can hook some gator clips up. And we have our gator clips running over here to our capacitor box. And we're going to begin with our original capacitor value, and then we will go up from there, I think. Okay, here we go. We're going to go with this test. You'll notice a lot more noise, and that's because of these leads are out and exposed, and we're actually adding a lot more lead, unshielded lead, in fact, into the signal, directly into the signal path. So that explains all the extra noise. So just disregard the noise, but let's listen to the tone. How about that for tone? Okay, let's talk about why that happened. I think, now I could be wrong, but I think that the reason that happened is due to this capacitor box sometimes shorts out a little bit, so I think that's the reason. As a matter of fact, I think that 0.022 capacitor in this box might be bad. So let's go up to the 0.033 instead. Let's see. Having some issues with cutting in and out. I'm not sure what that's all about. Let's go up to a .047. That's the value I predicted we'd go with anyway. It's a little bit more balls, but it's still kind of brittle. So let's play around with it a little bit more. Alright, for this test we have upped the value of this .022 to a .05. We've removed, or actually, excuse me, we have jumpered this R6. We removed it and just replaced it with a wire. And we have deleted this 1 meg resistor right here. Okay, let's see what kind of terrible noise this makes. Much less brittle already, that's for sure. What we are wanting to do now is we're going to have to come in here and clip the wire, that red wire right there, and I'll show you why. That red wire is this one right here that's coming from the potentiometer to this grid, and we're just going to put a little grid stopping resistor in here. And I think I might go with like 68 or 100K for this one because we're fairly close to where we need to be, probably 100K. Okay, the wires that they run from the potentiometer out to the next stage are not really discrete. They're going through this shielding, which they need to be going through shieldings. And over here we have silicone on both ends. There's a dab there on the pot end right there holding that connector, and there's another dab over here holding that connector, and that dab right there really is down in there, and I've been messing with it trying to get that off, and I don't want to really break that connection. So what I'm going to do, instead of installing it on this end, I'm going to install it on the potentiometer end, which probably isn't ideal, but we're going to do it this way anyway. So what I'm going to do is come in here in the center lead and clip it, and then straighten it, and then I will solder our component from here over to here. Just like that. Okay, I had briefly experimented with this capacitor right here, which is the interstage capacitor leading from the second stage of the 12AX7 to the output. This capacitor is normally a .022. I experimented with a .047, but there was too much bass that made it too farty, so I've gone back to the .022, and I've also, just as an experiment here, I've removed the capacitor for bypass on the output. Normally that is a 25 microfarad, I believe. Let's see, or is it a 22? It is a something that's not going to focus. Anyway, it is a 22 microfarad. So I've removed that for now, and let's listen to this briefly because I think we're getting fairly close. Still a little bit of that fizziness in there. A lot less brittle though, and a lot less of the farty bassiness. This speaker really isn't designed to handle, I don't think, what this amp is capable of even putting out. I think a new speaker would really probably go a long way on this one, and I might even see if I can dig up a little 8-inch speaker. Alright, let's look at some speakers now. I've pulled the Eminence out. That's that Chinese Eminence that was in the cabinet originally. These two speakers over here came out of 1950s-ish consoles, like television consoles, radios, phonographs, all in one kind of things. I tore down a couple of those in another video and brought these home, complete with the baffle boards. Also have this Tronics. I'm not sure what this is or who made it. It claims it's 20 watts at 8 ohms, made in Korea. We may try each of these individually without adjusting the circuit anymore, so we can kind of get a little bit of a comparison, see which one is warmer, because we're going for warmth now. All right, the speaker I thought was an RCA. It's a 32 ohm speaker, so we're not going to be able to use it. But this other speaker that came out of another one of those consoles, this one from 1950, I'm not sure who the manufacturer is, but I think this one's going to work fine. I plugged it in and hit a couple chords, and it's too late right now to be really doing a demo, so I think I'm going to leave this one in here. We'll do a proper demo tomorrow. In the meantime, I want to take a look at a couple other things we can do to the power supply of this amp. Alright, on the power supply, we can see here there's a layer of filtering. This capacitor right here is at 22 microfarad, and there's nothing coming off of it, so there's nothing being supplied at this node. So what we're going to do, there's a 220 ohm resistor right here. A 220 ohm resistor really isn't dropping that much voltage. So what we're going to do is actually just put a jumper, remove this and put a jumper wire straight across. These two capacitors in parallel like this will combine their values. So it'll be, 44, around about 50 microfarad total for this node, which I think should kind of solidify that power supply. It'll give a little bit more voltage to the output tube, and I think maybe tighten it up just a little bit. Now there's also a R11 right there, 220K resistor to ground. That's an unusual resistor to see in a power supply, coming off of a node to ground like that. I'm not sure what its purpose is supposed to be, but we are going to get rid of it. I see no purpose for it. I don't recall seeing it in any other power supplies that I'm aware of, so we're going to get rid of that. Delete R11. Coming through a little further, this little capacitor down here, this 0.1 capacitor, this is the node that supplies the 12AX7 plates up here, and we have an extra 0.1 capacitor basically in parallel with this 22 microfarad capacitor. I don't see the purpose in that either, so we're going to remove that one also. Okay, there's a C11 capacitor that went right there, and it's been pulled. Here is the, what is this one? This is the R10, no, excuse me, this is the R11 resistor that was going to ground, that weird one. And it's been pulled, it was right there. And here is the R10 resistor, and you can see that one has been blackened a little bit. See how it's kind of bulgy in the middle? And it's kind of turned a brownish kind of color, like it's been burning for a while. Well, that one has been replaced with a little wire right there in this position. Alright, we have the amp back on after making those changes to the power supply. Now let's check the output tube bias. First thing we're going to do is place our leads across the output tube bias resistor, like so, and record this measurement. We have 10.7 volts of drop across that resistor, so we'll write that down. Alright, the next thing we're going to do is we're going to measure from the cathode of that tube to the plate. This wire, the black one, is already connected to the cathode pretty much from that end of the resistor, so we're going to move this lead to pin 7, which is right here, and that is 333.7 volts. That is our plate voltage, so we'll write that down. Next, we're going to turn off the unit and also make sure the power to the unit is completely off. And we will measure across that resistor again, but this time for resistance. It looks like it's settled down to 216 ohms, so let's write that down. Okay, according to the RCA book, we should be looking about 300 volts maximum plate voltage right here for a Class A amplifier. Plate voltage is not as important really though as especially with modern tubes. More modern tubes are really more robust than the tubes that existed when this manual came out. So, you know, take this with a little bit of a grain of salt. The plate dissipation is really what we are concerned with, and 12 watts is what we want to try to nail. This is a Class A amplifier, so we can actually bias this to dissipate about 12 watts and still be okay. Alright, I've soldered in a new 360 ohm resistor, and I've taken the opportunity to bump up the wattage rating to 5 watts. I've also, when I installed it, I've also moved it. You can see the old part was over here, so I've bent my leads and moved it so that to the edge of the board, so it's away from all the other surrounding components, because these give off a lot of heat. And also I've lifted it off the board just a bit so that air can circulate around it. So let's put our leads back on it and complete our measurements. Alright, we ran the numbers again with our new resistor value, and it came out to 12.5 watts of dissipation, which in my book is close enough. Alright, here's a final walkthrough of all the changes that were made. On the first stage, I changed the bias or the bypass capacitor to a 0.05. Changed the second stage bypass capacitor to a 0.05. Left the interstage capacitor the same. Actually, I changed it for a little while, but then moved it back. I moved it to a later stage, the bigger cap. Removed the R7 resistor. Remove the R6 and put a wire in its place. Moving through, I changed this capacitor and doubled it in size up to a 0.05. Changed the output tubes bypass capacitor to a 10 microfarad. Changed the bias resistor to a 5 watt 360 ohm. I put a Zobel network on the output consisting of a 10K and a 0.0022. Put a, you can't see it right now, but underneath this pot down here, there is a there's a grid stopping resistor of 100K. Over here in the power section, I removed the R11 resistor, removed R10 also, and put a wire in its place. And I also changed the speaker to a 1950, pardon me, to a 1950 speaker out of an old console. So yeah, I think we're ready to give this thing a listen. so that concludes our presentation on this Epiphone Valve Junior. Hope you guys have enjoyed it. Some takeaways from this. Still has a little bit of that fizziness even after all the work that I've done. I don't really know what it's down to. Maybe, don't really know. It might be that I need to replace all of those capacitors that are in there. Maybe, maybe they were just, kind of on the edge of bad, even new. This amp isn't all that old. But, I can't imagine they were sticking the best capacitors in the world in there. But without redoing all those and seeing first, and I don't have any of that type of capacitor anyway. So, in the absence of those, I'm not going to mess with that. But at any rate, I do think it sounds a lot better than when I began. Obviously, this wasn't, an exercise in trying to see how many features we could cram into one of these. This was more about tone. So again, I hope you guys have enjoyed the video. If you haven't already done so, please hit the subscribe button. And for now, y'all take care.